Hello guys, we're group 3 and we're going to be discussing unmanned ground vehicles. My name is Jesse and I'm going to be talking about the brief history of UGVs. What is an UGV? An UGV is a vehicle designed to operate in contact with the ground without the presence of a human being. They're designed to operate either autonomously, semi-autonomously, or through a human operator. Although they can be found in the civilian sector and mainly used for military purposes, for applications such as reconnaissance, surveillance, and target acquisition, as well as path tracking and explosive ordnance disposal. The first primitive UGVs were developed in the 1930s by the Soviet Union, and these the teletanks, which were used for the Winter War, which are basically tanks remotely controlled by a radio from another tank. In 1942, the Germans built the Goliath truck mine, which was remotely operated and could carry up to 60 kilograms of explosive. It could also be driven, as we can see, up to 650 meters, and was also intended to destroy tanks, buildings, and bridges. In the 1960s, Shaky, the first UGV, was created by the Standard Research Institute as a result of a study for the Advanced Research Project Organization for Artificial Intelligence. So you can see it was a wheeled platform equipped with a TV camera, ultrasonic rangefinder, touch sensors, and a computer to help manage navigational tasks, which consisted of pushing large wooden blocks around its lab environment. It could accept commands instructing it to put although it was a failure because it didn't establish functional baselines for future mobile robots, it aided in the creation of an artificial intelligence research agenda. In the 1980s, two RSDA-oriented UGVs projects were undertaken at the Naval Ocean Systems Center. The first one was the ground surveillance robots, which explored the development of a modular architecture for the integration and control of complex robotic systems. It had an array of fixed and steerable ultrasonic sensors and built-in obstacle avoidance capabilities. It succeeded in demonstrating the autonomous following of a lead vehicle and a human. The other one is the advanced tail-operated dune buggy, which concentrated mainly on tail-operated control methodologies and on advanced, spatially corresponding multi-sensory human and machine interfaces. It demonstrated that it was possible to remotely operate a ground vehicle to transit complex terrain and remotely operating weapon systems mounted on vehicles. In 1990, the Unmanned Ground Vehicle Joint Program Office was created to coordinate the Department of Defense UGV efforts. As a result, the surrogate tele-operated vehicle came up as a desire to develop a tactical unmanned ground vehicle. It was intended to serve as a prototype system. Also, it was designed to be small enough to be transportable by a helicopter and at the same time fast to keep up with the tactical vehicle convoy, which moves at about 35 miles per hour. And it was controlled by a operator via stereo TV using radio frequency or fiber optic cable data link.
Hi, my name is Javier Ray Brooks, and I will be focusing on current UGV designs, which have been improved radically since the 1990s through Department of Defense funding, focusing on newer systems such as route clearance, suspected object identification, and the locating and defusing of IEDs. These upgrades have been determined through a cost-benefit analysis systems, which determined where funding would go in either small unmanned ground vehicles or manned transportable robotic systems. The iRobot software and technology upgrades that they receive through such funding have been able to upgrade the iRobot 248 field man transportable robotic system, which you can see here through 2 software upgrades and an advanced sensor suite. The advanced sensor suite included 1 wide-range robot vehicle vision system camera and a thermal camera, providing greater situational awareness and imaging in low-light environments. The iRobot's user assistant package improved greater operator unit control, GPS mapping, critical semi-autonomous features, reducing the overall workload for the operator. The iRobot 310 is a man-portable robot with dexterous manipulators and wearable controllers. It's a smaller and lighter version of the combat-proven iRobot PackBot and is able to enter inaccessible areas that are too dangerous for people. It's been used on a variety of missions, including reconnaissance, route clearance, hazardous material detection, and bomb disposal. Lowering swap is critical for UGVs, and that is size, weight, and power, which were critical in Quinitech's North American's lightweight throwable Dragon Runner 10, the DR10, which is 10 pounds, able to climb stairs, carry significant payloads, and maintain effective wireless communications for long distance. Typically, it's thrown or driven into potentially dangerous hostile environments to assess situations remotely before having to commit personnel. Through modular upgrades, it can also handle IEDs, deliver remote sensors, gather intelligence, and conduct surveillance. IEDs are one of the primary reasons why we use and are looking into upgrading UGVs, which is why Quinitech North America has a competition called Disrupt Challenge in order to further advance that research. The Bobcat Engineer was a winner of the mounted support category, and it is capable of route clearance, transportation, and logistics warfighter equipment, and is controlled using a tactical robotic controller, which a dismounted warfighter can operate the Bobcat from a distance. The large UGV implementation kit system was used on the Bobcat Engineer and is also used on several other vehicles. It can convert a regular vehicle into a UGV, and another such version of it is the Oshkosh Terramax, which you can see used on these vehicles here. It's proven in thousands of miles of field testing, capable of supervised autonomous navigation in either the follow or lead position, functions in all weather conditions, requires minimal human interaction and operating training, and each vehicle is capable of navigating independently, avoiding road hazards, and being able to follow in tight formations.
Hello everyone, my name is Victor Ingles, and I'll be talking to you all about the future designs of UGVs. The first one I have for you right here is called the Border Controller. It is developed by the IDF, which is the Israeli Defense Forces, and it's planned to replace the Guardian in their current reconnaissance missions. The unique thing about this UGV, though, it has a modified version of the Ford 350 Super Duty truck, which will serve as the main chassis for this. It has basic weapons implemented in case things go unplanned. It wants to be able to defend itself. You never know what could happen. It's expected to be on the field by the end of 2015. The next one I have is the Loyal Partner. It's going to have main weaponry that's going to be remote controlled. And the main purpose for this UGV, though, is going to serve as a scout for the main military forces due to its great maneuverability in diverse terrains. The good thing about the Loyal Partner, well, that it will decrease human casualties because less human life will be lost due to enemy ambushes or hidden explosives. Now, I named this one Unnamed Robot just because it doesn't have any name at the moment. It's just currently in design. But the main purpose of it is going to be a portable robot that will mainly also assist infantry soldiers. The good thing about this, though, is that it's going to be designed to be portable, that it can be carried by the soldiers themselves. It has the capability to monitor subterranean areas which would be beneficial because also it could detect and alert in case of collapsed structures or areas that have ventilation or poor lighting problems. The good thing about the unnamed robot, though, that it will be used in the military, but we can also apply to everyday life, like engineering problems, like I mentioned on the last slide, how it's able to detect collapsed structures. So we can use that to apply in our everyday lives. Thank you for listening to our presentation. We are group number 3, and we did UGVs.